If you work in an industry, you tend to know things before they're released to the general public. If you work with tech, you might know the features of a new device before it's released. I work with SETI, the search for extraterrestrial life. I got to know things early. Things that I wish I could forget. The first phenomenon we recorded happened way back in 1993, or so they tell me. That was a decade before I had joined SETI. The Hubble telescope had just sent back a peculiar piece of data. The star had just disappeared. Now, this isn't unusual by itself. Stars disappear for all kinds of reasons. But this one, it didn't go supernova. It didn't die naturally. It went dark over the span of just a few weeks. The researchers back then seemed to have eventually concluded that the star had been obscured by some kind of gigantic stellar debris cloud. They calculated it might be decades before its light was seen again. In 2007, during my first few years working at SETI, something similar happened. This time, 2 more stars disappeared in exactly the same manner. We were far better equipped to understand what was going on. The 2 stars in question were part of a binary star system, orbiting each other at a fairly close distance. We also got lucky because we happened to have been recording that column of space just as the stars vanished. The 2 stars went out sequentially, one, then 8 hours later the other. The way that particular star system was structured, we wouldn't expect a debris cloud to be anywhere near it. If there was a debris cloud in between the Earth and the binary system, it would be much closer to us than it. And if the cloud was closer to us than the star system, it would likely cover both stars simultaneously, but these stars vanished sequentially. At SETI, we had a saying, if you think you've found life, you probably haven't found life. We had that saying for a reason. The moment we ran out of normal hypothesis for what we were seeing, we started speculating. Perhaps the stars were being put out somehow, perhaps they were being shrouded, perhaps this, perhaps that. The truth was, at the time, Hubble wasn't sensitive enough to tell us any more. We were scientists, not science fiction writers. We filed it away for another decade and a half. That is, until we found our eyes. The James Webb Space Telescope had first come online a few months ago. Although official channels will tell you that it's still undergoing testing, the truth is, we had been pestering NASA to let us point it at our long list of anomalies since before it was built. At the top of that long list of anomalies was our disappearing stars. The telescope had a 0.1 arc-second resolution. That's more or less what you'd expect from a 100-megapixel camera, enough for us to be able to tell the difference once and for all between a dust cloud and whatever else was blocking our view. The images we got back surprised us again. There was nothing. There was no dust cloud. The missing stars were still missing. But we started to notice something. With the clearer image, we started to notice all the surrounding star systems were still orbiting the missing star. In fact, their orbits had tightened. It's almost like the stars were getting heavier somehow. And there was something else. The way the orbiting stars moved almost seemed like they traced the shape of something. It wasn't a sphere. The math pointed out that it was some kind of beam that was connecting the missing stars. The telescope also had another trick up its sleeve. NIR spec, near-infrared spectrography. Essentially, it can analyze the spectrum of radiation from a distant object, and it can tell you what that object is made from, down to each chemical element. The readings we got from the star didn't make much sense. First of all, they were cold. Almost as cold as the surrounding empty space. Whatever had happened to these stars had snuffed them out completely, or it somehow prevented their light from escaping. There was no piece of them left. What was truly puzzling, however, was the spectrography outputs. There were several familiar elements. There was way more oxygen and carbon than we'd expect floating in empty space. Whatever was in that space was 80 or 90% carbon and oxygen. What was even stranger, the other readings on the spectrograph didn't correspond to any known elements. In fact, the elements they were suggesting were too bizarre to even possibly exist. Speculation ran rampant. $10 billion worth of telescope later, and we were back in 2007, grasping at straws at what we were looking at. Obviously, this thing it couldn't be a natural phenomenon, but what was this thing we had discovered? Who built it, and why? The leading hypothesis always felt like we'd fallen back to science fiction, but this time somehow it felt justified. The theory being thrown around the lab that morning was Dyson spheres, massive solar panels built to completely envelop stars. They would be able to power entire civilizations for centuries. The construction of these massive structures had actually been theorized as one of the first signs of intelligent life that we would be able to detect. I still had my doubts though. I mean, we saw one of those suns disappear, and 8 hours later, the next sun disappeared. Who or what builds a Dyson sphere in 8 hours? It had crossed into beyond science fiction. Then there were the long beams or webs that connected the vanished stars. Perhaps they were a conduit, somehow passing the harvested energy back through, but to where? What kind of material would you need to build a structural beam that was light years long? Something was missing. There was something that we weren't seeing. Everyone was so fascinated by this mystery. In hindsight, I wish we'd never pointed the telescope at those stars. We observed the vanished stars for a few weeks longer, but eventually NASA needed it back for other things. They had identified some gamma-ray bursts and wanted some high-resolution pictures of the black holes that emitted them. We began preparing for another decade of silence like the phenomenon that occurred before. We received a message back the next day from NASA. NASA had pointed the telescope towards the gamma-ray bursts, but what they saw there, they didn't know how to explain or rationalize. There was no black hole. Instead, there was a small star system. Apart from the large gamma-ray bursts, there were several smaller, double-peaked gamma-ray bursts. This might have been interpreted as faulty equipment, if not for a paper published in 2015. The double-peaked gamma-ray bursts were something that every SETI member was familiar with. These were the hypothesized signatures of nuclear detonations. Originally, NASA suspected a black hole was emitting them due to the sheer size of them, but if this was some kind of extraterrestrial nuclear weapon, the size of the detonations would dwarf any weapon that humanity had ever conceived. And those were just the smaller bursts. Every now and then, huge spikes of gamma-ray energy flashed violently from the star system. But these lacked the signature double peaks of a nuclear detonation. Whispers spread around the lab that this must be some kind of antimatter weapon. The next images the telescope sent back, however, sent a collective chill up the spines of everyone that saw them. Long beams of what appeared to be empty space itself was reaching into the star system. They appeared to be crawling slowly towards the center, towards the star. We rushed and decoded to assemble them as fast as we could. With each image, we saw remnants of planet-sized explosions appear all over the beams as they approached. But slowly they began to fade and cease altogether. The beams had arrived at the center of the star system. They appeared to be swelling around the star. This was it. This is exactly what must have happened to the first star observed in 1993, and again in 2007. We were about to watch whatever this thing was blot out another star, but in real time. There was a sense of amazement, but the more we stared at the images, the more of an irrational feeling swelled up inside of us. It wasn't fear or horror per se, it felt almost like fight or flight, some primordial instinct to escape, to leave. We held our breath as we watched the projected image of the main sequence star, slightly larger than our own sun. At first, nothing seemed to be happening, but the next images showed a small shadow appearing on the edge of the luminous orb, soon followed by another shadow, and then a third. Image after image, the shadows began to converge. They formed a strange yet somehow familiar pattern as they blocked out the star's light.
"What is that?"
One of my colleagues gasped.
"They almost look like
She paused as if she was afraid to say the next word for fear of ridicule, but we all know what we saw in those images. Leaves, I said. Those things are planet-spanning leaves. We didn't go home that night. In fact, we didn't even sleep. As each image was resolved, a web of shadowy serpent-like vines had spread across the surface of the star. It seemed like light itself was somehow being suffocated until all that was left was a few slivers, and then we received an image where there was nothing. By that point, everyone in the room had realized the truth. The phenomenon we had been tracking for decades wasn't some hyper-advanced alien megastructure. The spectrography readings made sudden sense. Carbon, oxygen, trace nitrogen and hydrogen. We were looking at a plant. An enormous plant that spanned across light years. Much like terrestrial plants, it was seeking out light to fuel itself. Everyone was silent as the telescope continued to return data that was parsed and displayed on a giant monitor. Eventually, after what seemed like an eternity, a young astronomer spoke up from the far end of the room. This lost image seems almost like there's a new filament, except it's not on the same part of the infrared spectrum. This thing is almost yellow-blue. I froze. The feeling of building dread within me had hit some kind of boiling point. A wave of realization spread across everyone in the room. When stars zoom away from us, they tend to have a red tint known as a redshift. This plant's new filament wasn't red. It wasn't moving away from us. It was coming. How much time do we have? A solemn voice asked. The young astronomer took a moment to input the necessary calculations into his workstation. He paused, tapped delete several times in frustration, and re-entered the calculation. He stared blankly at the screen for a few seconds before weakly muttering, "We have less than 30 years." We had just watched this plant overwhelm a civilization that was, at the very least, thousands of years ahead of us technologically, and we had less than 3 decades. The observatory was shut down a few weeks after the incident. We had received legal documents preventing us from speaking out about this. I think most of us are abiding by them, but maybe it's pointless. I heard a rumor that JPL was trialing some kind of warp drive that could maybe allow some of us to survive. I can understand the motivation. When I used to look up at the stars, I used to be filled with wonder. Now I'm just filled with that sick desperation, that fight or flight adrenaline, like a gazelle that's seen a patch of spots in the tall grass but isn't quite sure what it's seen. I'll probably be found dead for recording this, but what does it matter? We're all dead anyway.